Okay, so we're going to close out this year's sequence. We've saved the best to last. We're going to have Zhijun tell us about paying consumers for their data. So this will run in the normal way. You'll have about 40 minutes. Andrew will give a discussion. There'll be some time at the end for comments. If you have points of clarification or so on, then I think Zhijun is okay for interruption, so he'll have some moments
Yeah.
set aside for pauses. And if you put things in the chat, I can relay it to him as well. Okay, so take it away.
Okay, thank you very much. I'm really excited to see old friends here. This presentation, as you can see from the title, is about consumer data and digital privacy. So because this is the seminar for digital platforms, and I guess the audience quite familiar with this digital economy. So I just give a very brief introduction about the importance of consumer data. So it's commonly understood that consumer data becomes a new oil of economic growth. We also know that there is a market for trading consumer data. This market is so-called data broker market, actually expanding quickly. So according to estimation in 2021, the market value is about 300 billion, and with a projected growth rate about 8% per year. So you may be curious about how much is your data worth. I try to find some evidence from one website to see if that can fit your case. So from this website, I find this is a very rough estimation of your data. So look, healthcare record worth is $250 per person, average price, and credit record is now only $0.3. The interesting question is, while we see a huge market for trading consumer data, but actually what's missing is a market for collecting consumer data. That is, in other words, do you know how much consumers are paid for their data? I never received any payment, monetary payment, I mean. So this is because the dominant business models of digital platform is really so-called free product for free data model. That is, digital firms, they provide essential digital products mostly for free, like search engine, online marketplace, social network. And meanwhile, so when you use these digital products, so consumer data is generated, and then digital platforms monetize your data, usually without direct monetary payment. So this is a dominant business model. I called it a missing market. So now there's increasing hot debate about whether consumers should be paid on top of this free service. So, of course, digital platform will argue, look, we have already compensated consumers with free digital service. Otherwise, they should cost $200, $300 per month. Of course, economists and legal scholars, they're not happy with this answer. They say, oh, that's not enough. Consumers should be paid more. Look, there's a very influential report by Bergman et al., so the so-called market design for personal data. They propose to allocate data control rights to consumers. The consumers should decide whether to share data and how much they can get compensated. So behind this hot debate is a key question, that is, what is the appropriate way to compensate consumers for their data? So in order to answer this question, it's very important to first understand the economic nature of consumer data. In this paper, I try to offer or provide a different angle to view consumer data as a commodity and try to highlight two key features of this unique commodity. First is so-called byproduct nature. So unlike a normal product, consumer data is actually generated as a byproduct. So some guys, if they never use social network, digital services, so digital platform cannot collect the data. So this property actually determines the interdependence between digital products and the data collection. That's the first important feature. The second feature is so-called privacy cost externality, and people often emphasize that now data collection causes lots of privacy issues. So here we just simply consider this as privacy cost. Because of the privacy cost, you have to compensate consumers. So based on these two features of economic nature of consumer data, then we try to answer the question, how should digital firms compensate consumers? So basically, digital firms are engaged in two interdependent activities. As I mentioned, first, they supply digital products or digital service. These digital services create consumer value, but of course, they pay the production cost or investment cost. Second, they use this consumer data, they monetize consumer data to generate large revenue. At that time, the data generating process imposes privacy cost to consumers. So these two activities are interdependent. And according to the current business model, digital firm cross-subsidize between these two activities. Now the question is this cross-subsidization optimal, or alternatively, should firms offer direct monetary payment in addition to free products? So this is the key issue that this paper is going to investigate. So here's the aims of the paper. So I developed a very simple theoretical model to analyze the compensation for consumer data and examine the interdependence between digital products and the data collection. And then I try to characterize the compensation mechanism for a monopoly digital firm. And using this model, I also consider the impact of data collection on competition and consumer welfare. And I also managed to derive some policy implications for digital privacy regulation. So here is a brief outline of presentation. First, I will introduce a simple model and then discuss the optimal compensation and the monopoly. Also, then I will discuss data acquisition and compensation. Finally, if I have enough time, I will discuss heterogeneous preferences and personalized pricing. I should pause here to collect questions. Okay, is there any questions? If no questions, that's good. Let's go briefly to the model. So the model is quite simple. We first consider a digital firm, let's say monopoly, supplies a digital product, and the quality of the product is labeled from 0 to infinity. And the firm faces convex cost function C of Q for the quality Q. There's a continuum of consumers with unit mass, and each consumer demands 1 unit of the digital product. So here we assume baseline model, homogeneous preferences for quality. So simply consumers derive a utility Q from using these digital products. And we assume zero reservation value for alternative options. Next, I try to use a reduced form to model the benefits of data collection. So I just assume firms collect consumer data at zero marginal cost. There are two types of benefits. One is called this data monetization revenue. That is, digital firm can generate a revenue R through multiple revenue streams. So here I just use a reduced form without point out the micro foundation. In the baseline model, we consider identical R across consumers, while in the extension, I also consider heterogeneity of R. Second type of benefit from data collection is so-called data-driven consumer benefit. Basically, I try to use a parameter to highlight that consumers actually can benefit from data collection. For instance, a digital firm can offer some enhanced functionality, personalized services with data. So this enhanced value is expressed by a parameter b greater than 1. So that is without data collection, consumer value is Q. With data collection, consumer value is enhanced by multiplied by B. B is greater than 1 or equal to 1. Is we call the benefit multiplier. And in the baseline model, we still assume homogeneous B, and while we consider heterogeneity in the extension. So now the cost side, as I mentioned, data collection imposes consumers privacy cost. So here I just simply use a parameter called theta, which varies across consumers with the distribution and assumes a normal longer concavity to ensure the uniqueness of the equilibrium. Okay, yes, I should pause here for a while to collect any questions on the model. Okay, David. Yes, please.
Thanks. Could you just clarify this B term again? This is simply the consumer uses it and it multiplies the benefit. It doesn't depend what others do. There's no network effects or externalities here. More consumers use it, my benefit from using it is greater.
That's a very good question. Yes, here in this baseline model, I just assume this this B is individual and homogeneous across consumers. Yes, there's no network effect. Thank you.
Okay, thanks.
Any other questions? No question. Let me continue. So as a first step, I just try to use this model to solve the optimal compensation scheme with a monopoly digital firm. So suppose the monopoly digital firm, call it M, supplies digital product. We call this product A. Yes, a benchmark. Suppose a firm does not collect consumer data. So it's a very simple question. So because consumers have homogeneous Q, the firm will charge a price for service or product equal to Q, and the profit is Q minus C of Q, and the optimal quality Q is determined by the equation marginal cost equal to marginal benefit, that's equal to 1, that's Q0. Now, under data collection, as I mentioned, I treat data as a byproduct. So here, with data collection, basically the digital platform supplies two products. One is digital product. Second is consumer data. So the platform actually can bundle consumer data with product A because consumer data actually is a byproduct. And it can offer two options, respectively. One is I call pure bundling. That is a case that digital platform of consumers, okay, I offer you a product and I collect your data. So that's the option. Second, called mixed bundling. The digital platform offers a bundle, as well as you have another option. If you don't want me to collect your data, I charge another fee for the digital product. So basically, under mixed bundling, consumers have two options, a bundle or a standalone digital product. So in this presentation, I will focus on the characterization of optimal mixed bundling scheme. That is, the digital firm offers a bundling scheme as it's so the firm commits a consumer value BQ and also charges a price. So here price can be positive or negative. So if price is positive, means that consumers pay a fee for the digital product on top of data collection. If P is negative, means that the firms actually provides monetary subsidy. On top of that, the firm also offers standalone digital product we call SA. That is, you can choose digital product only or without sharing your data, but you have to pay a price PA. So of course, in equilibrium, because consumers have homogeneous variation, PA will be set equal to Q. So ensuring full consumer surplus is extracted. Okay, so Andre, yes.
Hello. Is it never optimal for a firm just to buy data?
So very good question. So I will discuss this later, but here the underlying assumption is firms can collect consumer data only if they provide this service because data is generated when consumers use service. In other scenarios, consumers can buy data from the market, but this is not the situation I'm discussing now. Thank you. Is it clear? Okay. Thank you. So now let's consider consumer utility for two options. The net utility, you have seen that if consumers choose a bundle, they receive a utility BQ minus P. And there's also privacy cost. So BQ minus P minus theta is the consumer's utility from bundling. Remember that theta is heterogeneous across consumers, while the consumers receive 0 from buying the standalone product. So in this monopoly pricing case, it's very simple. We can find a cutoff threshold for theta that is tau equal to BQ minus P. Consumers with theta less than tau will choose a bundle and others choose a standalone product. So now back to the firm's optimization problem. The firms choose P and Q to maximize its profit. Because consumers with theta less than tau choose a bundle, so the F tau times R plus P is the total revenue from the bundle. Because the digital firm receive a monetization revenue R, on top of that may receive a P, it's a price charge to consumers, but P can be negative. On top of that, the firm also receive revenue from standalone product, selling this to consumers choosing that product, 1 minus tau times Q. So this profit function reflects the connection of two interdependent activities. Supplying digital product A generating base value, while collecting consumer data generates revenue R and consumer benefit BQ. So with this price, actually, the monopoly can extract consumer surplus. So using this price P equal to BQ minus tau, substitute into profit function, I can rewrite the profit function as follows. So here you can see on top of the net profit from digital product, Q minus CQ, that's the same as without data collection. There's extra benefit from data collection. First, B minus 1 times Q, that is the added value for consumers they can extract. And R is the monetization benefit, revenue. So that's the total added value from data collection, B minus Q plus R. But of course, because consumers have heterogeneous cost, so means that needed to compensate consumers under this uniform pricing. That is compensation equal to the price cost of the marginal consumers, data equal to tau. So this monopoly optimization problem is quite simple. We can just characterize the first order conditions for Qm and tau m as follows by use these two first order conditions. So look at the first equation, C prime Q equal to 1 plus B minus 1 times F of tau. So if B equal to 1, then the quality of digital product is exactly the same as without data collection. So this means that data collection can improve the quality of digital product if and only if it can generate benefit to consumers. If B equal to 1, in the case the digital firm only use data to monetize only monetize consumer data and to generate revenue from data without providing extra benefit to consumers. In this case, the optimal Q actually is the same as without data collection. So the following proposition actually summarizes the equilibrium of mixed bundling. So consumers opting for the bundle received a net surplus, which increases with B and R. And data acquisition improves the product quality if and only if B is greater than 1. And also, we can characterize conditions for monetary payment. That is, P is positive if R is sufficiently large. Monetization revenue is sufficiently high. In this case, the digital firm started offering a monetary subsidy to consumers. And finally, in this case, data acquisition increases profit and consumer surplus. So I just pause here for a while. Any questions about this? Yes, has
an observation. You're imposing the same quality whether I give up my data or not. Like in principle, you could allow for different qualities for
yes, so qualities are different.
I don't think qualitatively it would change the results at all.
So here, if you do not share data, the quality is Q. If you share data, the quality becomes B times Q.
Right, but it's the same Q.
Yeah, same Q, yes.
Yeah.
So, but just multiply by B.
Yeah, in principle,
Yeah.
you can give different features if I share data as well that aren't enhanced through the use.
Yes. So I started this considering a general kind of function, so with different benefit function, but it seems very difficult to solve the model. So here I just use a reduced form, this B times Q. B here is the multiplier. Okay, yeah, thank you. Any other questions? Okay. So next step, I try to use the model to discuss or examine some applications. First, the discussion is about the mechanism of so-called data intermediaries, like in the Benjamin or their paper introduced a mechanism of data intermediary for selling data. Basically, a data intermediary is a kind of agent. They can sell data on behalf of consumers. They can install a software on consumers' web browser. So important features, data intermediary usually does not provide a digital product. They just collect consumer data and sell data for consumers. But it's very important with data intermediary, it actually opens the door for consumers with more options. That is, now consumers can choose to still use the monopolist digital product while selling their data through the intermediary, not only through the monopoly. That is, the intermediary and the monopoly are competing in selling consumer data. So we consider two options. One is consumers still choose to monetize data with the monopoly, so still choose the bundle. Then the utility will be UB of theta equal to BQ minus P minus theta. Alternatively, they can still use the digital product, but can sell data through the intermediary. We consider intermediary can generate revenue RI. That RI can be higher or lower than R, can be more efficient or less efficient than the digital firm. But then because of consumers, they incur the same private cost. That is a Bertrand type competition between two options. That is going to affect product quality and consumer welfare. So, so roughly speaking, I have can find three different kind of situations. First, with inefficient intermediary, that is RI is sufficiently low, below this cutoff threshold, then the equilibrium outcome remains the same as without intermediary. Second, with the efficient intermediary, that is RI in the middle range, then in this case, still digital firm wins this competition, but competition leads to high quality and consumer surplus. In order to win this competition, the digital platform offers high quality QI star and the intermediary, greater than QM star under the monopoly case, and more consumers will use the digital service. Third, highly efficient intermediary. If intermediary can offer revenue or benefit I is greater than R plus B minus 1 QI, that is the revenue is high than the total benefit from the monopoly, then data intermediary collects consumer data, wins the competition, but the digital platform still offers digital product. In this case, actually, the product quality will reduce to the benchmark quality Q0 without data collection, but consumer surplus is still high. So that's the result of the competition. So any questions? Okay. So the second application is I consider competition from the entrant. So what's the impact of data acquisition on competition? Suppose there's so entrant want to enter the market competing with the incumbent. The incumbent monopoly has a data has a capacity to collect and process consumer data, while the entrant does not have such kind of capacity. So it supplies a better product, digital product with a quality premium delta, but can commit not to collecting data or does not have capacity to processing data. So here, I just assume this product quality is given before competition without considering investment problem, and the investment cost is sunk. Now, suppose the incumbent commits to pure bundling, that is, offers consumers with data collection and digital products only without offer standalone product. So in this case, there's asymmetric competition between the incumbent offering two products, a bundle, and the entrant offers a standalone digital product. So incumbent has advantage from data collection. That is, look at this beta is the advantage over the entrant. While meanwhile, the entrant has advantage of quality that is modeled by delta. So this asymmetric competition actually leads to a unique equilibrium. So in this equilibrium, actually, we can show that firms, the incumbent firm comes to pure bundling. It's never optimal to offer mixed bundling. And the data acquisition actually impacts competition in two opposite ways. First, the incumbent benefit from data collection. There's enhanced competitive advantage from this beta. This enhanced value actually can intensify competition. Second, because of consumers have heterogeneous privacy costs, that create a product differentiation. So actually softening competition. And then the interaction between these two effects leads to different types of equilibrium. Depends on the comparison of parameter. So here for comparison, I just fixing the parameter delta and consider the parameter beta that is competitive advantage. So with large beta means if the incumbent has greater data advantage, competition is intensified. As a result, the entrant charge the price below delta. That is, the entrant cannot recover or recoup this quality premium. Actually, in this case, the competition benefits consumers while harms the entrant. While when this benefit is small, with weak data advantage, actually competition is reduced. We can see that because of this competition softening effect, the entrant charges a high price above delta, harming consumers. And if beta is sufficiently small, actually the entrant can earn a profit more than delta. That is more than extracting all these quality premium. So in this case, the entrant firm actually benefit from the rival's data collection. Okay, so this also offers some policy implications. because existing studies on this data collection and acquisition find that digital firms use data for personalized pricing and can intensify competition. While actually, it's also important to emphasize that because of the heterogeneity of privacy cost, such kind of competition actually can lead to other effects, softening competition and harm consumers. While it's very important to ban pure bundling, as long as the incumbent keeps offering standalone products, competition will reduce price for standalone product. Okay, so with the last for 5 minutes, I just want to discuss the last topics about personalized pricing. So we all understand that personalized pricing is now quite a hot topic, and there's some interesting effects, can increase efficiency and extract consumer surplus. But the most research on personalized pricing does not consider privacy choices. The only exception is Andrew's paper with Zhijun. This analysis is quite different from theirs. So what's the effect when consumers can choose whether to share their data or not, and the privacy cost is private information? So I briefly discuss the modeling feature. So I just consider heterogeneity in this data-driven consumer benefit. That is BQ equal to 1 plus X times Q. Here X as distribution from 0 to 1. And consumers learn their preferences, X and privacy cost before they make the decision. And assume X and theta, they are not correlated. So for the trackability, I also focus on the uniform distribution of theta. So still consider the competition between the incumbent firm I can collect consumer data and offer personalized price, because when I offers collect consumer data, it learns benefit X as parameter X, and it can offer personalized pricing based on X, that's PIX. While the entrant offers digital product only, it does not collect data, so it charges only a uniform price on digital product. So we consider firm I comes to pure bundling, then consumers have two options. One is choose the bundle, receive the utility with theta x, UI theta x equal to 1 plus X times Q minus PIX minus theta. If they choose entrant standalone product, they just receive UE. So now we want to compare the personalized pricing with uniform pricing. So suppose firm I uses personalized pricing, and then compare with situation firm I uses uniform pricing. So under personalized pricing, we understand that PIQ can be used to extract consumer surplus. But the key issue is because consumers have private information on theta, so it still has to compensate consumers with this tau x plus UE, where this is heterogeneous. So this actually changed the result. Firm I must leave positive surplus for each consumers. And this surplus, you can still try to extract the extra surplus by PIX. So under this setting, when consumers cannot fully extract consumer surplus through personalized pricing, as a result, actually, it's quite interesting. So I compare to the uniform pricing and find that personalized pricing by the incumbent firm results exactly the same equilibrium price and profit for the entrant. That is, whether or not you use personalized pricing does not affect the entrant's equilibrium price and profit. Of course, this is the result I derived under uniform pricing, uniform distribution of theta. Meanwhile, of course, the incumbent earns high profit. And for consumers, the impact is different. So consumers with high valuation, they actually extract more surplus, while with low valuation, they benefit and reduce both consumer surplus and overall social wealth. So that's the main finding, actually different from the existing literature. I guess I'm running out of time. So the related literature, I just will skip, but needed to mention or address this large literature on this so data collection. And also this paper is related to personalized pricing. Finally, I would like to address just the main limitations. First, so we assume data monetization revenue is exogenous given without providing micro foundations. That's its main limitation. Second, as I also mentioned before, I do not consider network externality in data acquisition. That's also a major limitation. Thank you. I should stop here.
Thank you very much. And next up, we'll have Andrew discussing the paper.
Okay, so thanks to the organizers for the chance to discuss this very interesting paper. So as I think you saw it, can you hear me?
Sure.
Oh, sorry. So it touches on many interesting topical issues, lots of things that I've been thinking about. So it was a nice opportunity to read the paper. So at a very high level, I think relative to the literature, which is quite large on this topic, one key feature is that the paper takes seriously the fact that data is a byproduct of our activity online. And then it sort of combines that with privacy costs in a way which people don't usually do. And importantly, it also allows for this possibility for firms to bundle or unbundle the actual activity we do in the data that is collected. So there's lots of results. I won't go through them all. One that you didn't go through in the presentation, which I thought was very interesting and come to later, is the fact that you might get differentiation in the type of business model that might arise. So my kind of very high level impression before I go through some more detailed comments is that when I was reading the paper, there was a lot going on, right? So you start off with this model where we have this endogenous quality, we have this monopoly case, and then there's kind of a question about what if we have the data intermediary. You also have the policy part on the DMA, which you didn't go through in the presentation, but I thought was interesting. For me, the first half of the paper could even be a paper on its own, if you just flesh it out a little bit more. Then you have the second part where you turn to competition, mergers, business models. You could even make a separate paper out of that. So I'm not sure if this is a particularly helpful comment, but as a reader, I felt like there's a lot of things going on and some of the assumptions are changing, right? The quality is endogenous at the beginning, later on it's exogenous. So you might even think about splitting this out into two papers. I don't know if that's helpful or not. In terms of more detailed comments, so I have some comments about the assumptions. So if we start with the baseline model, so the monopoly case, you assume that when you use this product, you're going to generate data, and that can do two things. It can be monetized by the firm itself, and it also generates this benefit multiplier. So I think some of these things came up already with Heskey and David. I mean, I would wonder a little bit about, well, first of all, functional form, but also thinking about more generally explaining why you model things in this way. So for example, the monetization for the firm, this generates a benefit for the firm. There's no cost for consumer, right? So if I think about that as personalized advertising, there might be additional costs of that. If I think about personalized pricing, there could be costs or benefits for the consumers, right? Depending on the market structure. Another thing which kind of struck me was the way you model this is that it doesn't depend on the Q, right? So it's just this R. But the benefit that comes from the second part, so the data-driven benefit for consumers, that does depend on queue. So I wonder why you model these in very different ways, right? I could imagine that it might depend on queue because maybe some kind of higher queue means more engagement. But in that case, why doesn't the benefit to the firm also depend on the queue? So I'm not suggesting you necessarily change the model, but I think you might want to kind of justify a little bit more why you make these particular assumptions. This is more what I think David was referring to. This is very much within user learning, right? Whereas you might think more also about cross-user learning. And although you didn't have time to go through it, I think that would be relevant for the policy comparison when you talk about the DMA, right? Because there might be a question about which should be the baseline model and should that depend on the data that has been obtained from other consumers. So this kind of within a cross-user learning distinction might matter there. Some other comments. So I mean, you set it up in such a way that the privacy distribution is always like it goes from 0 to something very large. So you always have an interior solution. You might think about playing with that. What if it's shifted up, right? So everyone is privacy conscious, and so maybe the firm has to work harder to get consumers to share their data. Not sure if that would change anything, but it might be worth thinking about that. I have some other comments and assumptions. We could maybe discuss that later, or maybe just let me mention very quickly on the results. So you have this result about you would get differentiation in the business models, which I thought was very interesting and unexpected. So the way you model it is that you have these two firms, they're slightly asymmetric in terms of their capabilities, and you have one of them going first and then the other one going second. Now, I was a little bit uncomfortable with that because if they're asymmetric, it felt a little bit arbitrary which one you was allowing to go first. You said that everything holds if they move simultaneously. So for me, that should be the benchmark model probably. One thing I was missing when I was reading it was the intuition. So why did you get this result? You give a very mathematical explanation, but I would like more of an economic intuition. And kind of related to that extension, but something which I think applies more broadly, is that you assume consumers are very rational here in their privacy choices. They understand what's going to happen. They have this privacy cost. Especially for this part of the paper, you might want to think about consumers who are more behavioral, who may not fully internalize the impact of their choices. And that might also have an impact on whether firms want to differentiate in the way that you have. I think I'm out of time, but if I can just have one more minute to mention. So about the personalized pricing part of the paper, again, this is something I'm obviously very interested in. For me, you went a little bit too quickly here in the text. So I would have appreciated a little bit more information on, exactly who is moving, when, what is the order. I can kind of guess what the order should be, but it would be good to flesh out a little bit more. And as you mentioned in the presentation, also in the paper, you have this very stark result that the firm E, the entrance price, doesn't change. So that, I guess, is driven by the uniform distribution because it's related to the expectations. But that suggests to me that you could probably get a sharp sufficient condition for actually the price to go up. I don't know which way you have to change the linearity, but I guess it should be possible to do that. I think that would be an interesting and very valuable result. Okay, so I should stop there, but just to say, I think it's a very nice kind of workhorse model that people could build on, and you may want to split it up into two papers to utilize that.